CryEngine, Unreal Engine, Frostbite Engine. Game engine names are often used as buzzwords by companies to showcase advanced graphics or physics in a video game. But have you ever wondered what they actually do, or why you should even care? My name is Blaze, and you're watching Tech at a Glance. Game engines are designed specifically for the creation and development of video games. Think of them as a template that dictate the possibilities and limits of how each component in the game actually works. Some examples include sound, lighting, physics, and animations. Say one game features destructible environments. Using the same engine on a different game allows developers to feature destructible environments without actually redesigning how that function works. Usually, a game developer will design a specific game engine, say the Frostbite Engine, and gradually modify it to add new features for subsequent sequels. Hence why we've seen Frostbite Engine 1, 2, and 3 in the past several years. There are many components, or mini-engines, contained within a singular, all-encompassing game engine. Let's take a look at some of the basic functionalities that most users are familiar with. The most important is the rendering engine, or renderer. This is responsible for taking code from a programmer and translating it to form objects in a game environment. Based on your perspective in the game environment, the renderer will project that as an image onto your screen. Depending on the characteristics of the object, a renderer will determine whether it will have a smooth or rough texture, its color, shape, and size. The reason why you've been seeing more realistic and lifelike games is because render engines have been gradually becoming more powerful over the years. Modern rendering engines also control game lighting. They simulate how light bounces off objects in the game world and create shadows from that. Because it takes a lot of power to precisely render individual light particles though, most game engines will aim for an approximation of light rather than exact realism, doing this fast enough to give the gamer a more fluid game experience visually, while still making things look real enough. How objects interact with one another is controlled by the physics engine. This is responsible solely for the simulation of certain physical systems, such as rigid body dynamics, fluid dynamics, and soft body dynamics. Say your render engine creates a blanket object and a ball object. The physics engine will determine that if both are dropped, the blanket object will fall much slower than the ball object. The physics behind car crashes, destructible environments, your character stopping while walking into a wall, that's all the physics engine in action. Then there's artificial intelligence, or AI. The point is to simulate human-like intelligence in characters not controlled by the player. This includes walking around the game world, not running into walls, hiding behind cover when getting shot at, or staying on the racetrack when driving. Without AI, characters in games would be standing the entire time doing nothing. There are many types of artificial intelligence. Some as simple as only telling all characters in a scene to walk from point A to point B, to complex behavioral chains that change the actions of characters depending on what you do as a player in the game. Those are some of the main functionalities of game engines. But why is it there are so many game engines out there if they all have to provide the same set of features anyway? It turns out that each game engine has its own strengths that differentiate it from the others. Game engines for driving games will have a bigger focus on rendering car models and driving physics. Engines for shooting games, on the other hand, will have a big focus on AI and physics. Game engines for open world games will have a more balanced focus since they need to simulate entire virtual worlds in as realistic a way as possible. Some of the more well-known game engines today are DICE's Frostbite Engine, which features destructible environments, Crytek's CryEngine, which is known for hardware-pushing beautiful graphics and physics, and Epic Games' Unreal Engine, which is known for its compatibility across many platforms such as Windows, Android, consoles, and even web browsers. That's not to say that only professional game developers can use game engines. Some game engines are released as open source or are freely available to the general public, meaning that literally anyone can learn how to make video games. We hope this gives you more insight into how video games actually run under the hood. Next time you're playing a game, why don't you try to figure out what game engine it's actually running on? In the comments below, please let us know what other topics you'd like for us to cover in the future. And if you like these more technical topics, please let us know as well. Please subscribe for more of our videos from TechAtAGlance, and check us out on Facebook and Twitter. We hope to see you next time.